Since its beginning, Tektronix has been successful by producing quality products. You have a major role in maintaining this tradition of quality. As a technician, you're usually the last person on the product line to affect quality. To avoid degrading product quality, you need to exercise caution. Anytime you resolder a connection, chances are the appearance and reliability of that product have been lessened. Here's a circuit board on its way to a technician. Notice the connections. They're shiny, with the proper amounts of solder and no signs of heat damage. The insulation is the correct distance from the connections. There are no stray wire strands, no burned or melted insulation. Note the lead dress and component dress, all good. This is how a board should enter your area. More important, this is how the board should leave your area. In this presentation, we're going to do three things. One, we'll talk about the major items you need to consider when modifying or repairing printed circuit boards. Two, we'll also show you repair methods that greatly reduce the danger of damage to circuit boards. And three, we're going to show repair methods available at repair stations. You may not solder as often as an assembler, but choosing the right soldering iron is important. Here are some guidelines for choosing soldering irons. For smaller areas and heat-sensitive components, use an 18 to 25 watt iron. For larger terminals, where more heat is necessary, use a 40 to 65 watt iron. When choosing an iron, start at a lower wattage. If proper results are not obtained, go to a higher wattage. Typically, you may not use your iron for days, so a good choice would be an iron with variable temperature control. An iron with an on-off switch is also desirable. If this is not possible, your next choice would be an outlet that can be switched on and off. Choosing the right tip is very important. Tip size and shape are determined by the required type of work. Choose a tip configuration that will give maximum contact between tip surface and work surface. A tip smaller than the connection cannot do an efficient job of heat transfer. A tip larger than the connection results in damage to adjacent circuitry and is difficult to accurately place on the connection. A tip should have a long life, so the solid metal should not erode rapidly and dissolve in the liquid solder. In the past, most tips were made of copper. Unfortunately, tin-lead alloys attack and dissolve the copper during operation of the iron. This dissolved copper contaminates the solder joint. Also, these copper tips must be filed and refiled to keep their shape. With all these problems, the life of a copper tip was relatively short. Today, we have ironclad copper tips. Ironclad tips retain their shape and should never be refiled. Tips don't have to be changed as often because ironclad tips have a longer life. To ensure the longest possible tip life, before soldering, make sure the tip is well tinned with solder. This is a simple process. For a new or reworked tip, wrap several turns of solder around the tip of a cold soldering iron. As the iron heats, the solder melts and coats the tip face. Spread the molten solder evenly over the tip face by gently wiping it on a wet sponge several times. Normal use of an iron produces a buildup of oxides and dirt on a tip. Simply applying rosin core solder to the tip provides continuous tinning of the iron. This tinning keeps the tip clean, which is essential for a clean connection. This coating of solder also greatly increases the transmission of heat from the iron tip to the work. When you remove a soldering iron from its holder, clean the soldering tip on a wet, sulfur-free industrial sponge. The wet sponge provides a thermal shock to break free and remove secondary oxides of tin and lead from the tip's surface. During long idling times, occasionally re-tin the soldering tip. Also, before turning off the iron at the end of a work day, tin the tip and put the iron in the holder. Mechanical tip freezing is something we've all encountered in the past. Today, most tips have anti-freezing features. These can be identified by the coating over the copper. Depending on use, to prevent freezing, uncoated copper tips must be removed regularly. Cleaning the iron daily will prevent tip freeze-up, but if a tip does freeze up, let the iron cool and remove the tip from the barrel. Slight tapping will clean the bore. Never give the iron a strong physical shock. Solder and components can be properly removed from circuit boards using appropriate methods. The heat and shake method involves melting the solder joint and shaking the molten solder from the connection. This method may include striking the circuit board against a surface in order to shake molten solder out of the joint. Since you don't have control as to where the molten solder goes, don't use this method. Not only is it dangerous, but it may create shorts or other functional deficiencies. This method is unacceptable and should never be used. The wick method uses braid saturated with flux. This method should never be used for removing solder from plated-through holes on printed circuit boards. However, wick may be used to remove solder from appropriate places such as runs and connectors, for example. Here's how to use it. Apply the braid between the solder and a heated soldering iron tip. Only the heated braiding should contact the solder, not the soldering iron. Once the solder melts, it's absorbed into the braiding. Used portions of the braid are cut off, so new braiding is ready when needed. Again, the solder wick method should not be used on plated-through holes on circuit boards because surface pads are easily lifted by the wick. The heat and pull method should be used only on two lead parts. To remove a component, grip one of the component leads with long-nosed pliers. Touch a soldering iron to the lead at the solder connection. Don't lay the iron directly on the board. When the solder begins to melt, pull the lead out quickly but gently. Repeat this action on the other lead. Then heat the pad where the part was removed and remove solder from the hole. Bend the leads on the new component to fit the holes in the board. If the component is replaced while the board is mounted in the instrument, cut the leads enough so they just protrude through the board. Insert the leads into the holes in the board so the component is firmly seated against the board. If it does not seat properly, heat and add solder and gently press the component into place. To protect heat-sensitive components, use a pair of needle-nose pliers or other heat sink and hold the lead between the component body and the solder joint. Clip any excess leads that protrude through the board. Clean the area around the solder connection with a flux remover solvent. Be careful not to remove information printed on the board. Refer to your soldering handout for proper iron position and solder application. The cut part lead method consists of cutting the lead between the body of the part and the solder connection. When the connection is heated, use needle-nose pliers to pull the lead out of the hole. Remove solder from the hole and add the new part. This method of removal is very good for removing machine-inserted parts, such as resistors, because of crimped leads on the back of boards. Resistors are inexpensive and the cost of a new resistor is much less than replacing a circuit board damaged by heat. Sometimes you may find it necessary to lift a part lead or a transistor lead to isolate electrical problems. But it may be safer to cut the part out than to risk ruining a circuit pad or run. The most frequently used solder removal method uses a spring-loaded desoldering tool, commonly called a solder sucker. A solder sucker is not recommended for removing static sensitive parts, unless it is a low-static solder sucker. To remove solder on appropriate parts, push in the plunger on the solder sucker. Heat the joint where solder is to be removed. Place the tip of the solder sucker on the joint and press the button on the side of the solder sucker. Parts with more than 3 legs should be removed at a repair station. There are many methods available for removing these parts. For your information, here are some details about these methods. One method uses a solder pot to heat all connections at once. The most recommended method for removing multi-leg parts is the solder vacuum method. This consists of a hollow-tipped soldering iron connected to a vacuum source. The hollow tip is placed over the component lead. As the solder melts, move the tip in a circular pattern to keep the component lead from bonding to the side of the hole during the extraction process. When the solder becomes completely fluid, the operator starts the vacuum, which extracts the solder and cools the connection at the same time. This process occurs so quickly and such a small area is heated, there's usually no heat damage. If it is handy to your area, the solder vacuum method is best for removing any part. Now, let's talk about wire damage. This is a common problem that can be remedied with a little care. When removing a wire, be very careful where the iron is placed and the amount of heat used. Wire insulation is easily damaged by too much heat. When soldering in close areas, always be very careful where you place the iron. Otherwise, adjacent wires can be damaged. If damage does occur to insulation on a wire you're removing and intend to use again, strip back the melted and damaged insulation. Be careful not to nick the wire strands of the wire you are stripping. Nicked wires break easily. When the wire is properly stripped, insert the wire and solder the connection, taking care not to melt the insulation. If damage occurs to a wire or wires in a bundle like this, then the wires should be replaced in a proper rework area. Another wire problem is loose strands. If a loose strand of wire comes in contact with adjacent circuitry, a short occurs. When resoldering wires, be careful that there are no loose strands. If necessary, cut off the end and restrip. For most jobs, you'll use a rosin flux core solder of 63% tin and 37% lead. This is identified on the spool as SN63. If a lower melting temperature is needed, then a 2% silver-bearing solder should be used. Silver solder is very expensive, so don't use it unless necessary. Components with silver in their terminations, such as chip resistors and capacitors, and ceramic connectors, must always be soldered with silver solder. This prevents leaching of silver from the termination. Sometimes, for rework purposes, you may need to reflow a solder joint. Apply a small amount of rosin flux to the joint. Then apply the tip of your iron. You can achieve a good shiny joint without adding solder. To be effective, a flux must be corrosive. Only residues of water-white rosin flux should ever be left on any assembly, and these only under special conditions. In general, cleaning flux is a must. Water-soluble flux material can be removed with a detergent wash. Never use Freon solvent. It damages electrolytic capacitors and it should never be kept at your bench. Only alcohol and photocol are recommended. While storing cleaning agents at your bench, make sure they are in proper containers and labeled. These dispensers make excellent containers. A small amount of cleaner is dispensed when the top is pushed down. The remaining cleaner is left uncontaminated. Never use sharp tools or instruments to remove flux residue. When using alcohol or photocol, be careful not to remove markings from components. Pipe cleaners make good flux removers. To use a pipe cleaner, bend it in half, dip it in alcohol, and apply to the specific area to be cleaned. Rub gently. Flux residue will be absorbed by the pipe cleaner. Acid brushes are not as effective. The flux residue is only diluted and left to dry. Be careful when using circuit coolers. Temperature and static sensitive parts are sometimes damaged by improper use of these coolers. Also, Freon coolers can damage electrolytic capacitors. The most common cause of circuit board damage is excessive heat. Heating a connection too long will melt the bond between the pads or runs and the board. A rule of thumb is never heat a connection longer than 2 seconds. Before applying heat again, allow the connection to cool completely. This allows the pad and board to completely return to a normal state. If a pad has been lifted due to excessive heat, what can be done? If it is not a multi-layer board, a rivet may be used. A repair person can select the proper size rivet for the hole and also properly install the rivet. Don't rely on the rivet itself to make electrical connection, so when resoldering, solder should flow over the rivet edge and onto the pad area. If a pad on a multi-layer board is lifted and there are no interlayer connections to the hole, a rivet may be used. If there are interlayer connections, a rivet is not a reliable connection. If a connection has been heated enough to loosen a surface pad, the interlayer connections probably have been damaged due to heat stress in the board material. This is a cross-section of a normal soldered multi-layer board hole, including a component lead. Here's the same hole with heat applied. As temperature increases, layer 2 acts like a heat sink and proper heat transfer is reduced through the length of the hole. Here's a look at the hole when excess heat is applied, using conventional methods. Sufficient heat transfer is achieved, but between layers 2 and 5, a tremendous amount of excess heat causes melting, burning, crazing, delamination, measling, and expansion. This damage may not be visible on the surface of the board. If a hole with interlayer connections needs repair, take the board to a repair person qualified to work on multi-layer boards. Never rely on a rivet to complete interconnections. In some cases, the runs may be strapped to complete the connection. Also, you need to consider whether the integrity of the circuit would be affected by the extra capacitance or inductance of these straps. When strapping is appropriate, use an approved strapping wire, not bare strapping wire. Long straps should be glued down every 1.5 inches to prevent being moved or broken during vibration. For best results, have strapping work done by experienced people at a repair station. Any strapping degrades the appearance of a board, so whenever possible, straps should be placed on the back of the board. If you're not sure whether a board looks good enough to ship, consult your manager. Excessive heat or poor solder tip maintenance can sometimes cause a run to be pulled from a circuit board. A good repair person at a well-equipped repair station can do wonders for a board with lifted or missing runs. With run repair strips and glue strips, runs can be re-glued or replaced, and the repairs can be almost undetectable. Many repair stations have the capability to repair damaged gold pads or connections with a re-golding tool. Repair stations may be able to save boards you once thought were unrepairable. Multi-layer circuit board repair should always be performed with the utmost care and best possible techniques. To have multi-layer boards repaired, utilize qualified personnel who are trained in advanced techniques. During removal and installation, some components require special handling. Here are some examples. While soldering, always heat sink these large hermetically sealed capacitors. LEDs like these have more than a 50% reject rate when any stress is transferred internally. LEDs should be held with pliers like this and then bent. Never do this, not even slightly. When removing power transistors, always be sure to replace the mica insulator with a new one and apply silicone grease. Here are some examples of components that require special handling and should not be worked on at your bench. Cam switches that require special fixtures. Very large components that require a 60-watt iron should always be removed at a rework station by experienced personnel. Always inquire as to what parts in your product may require special handling. Let's take time to review some of the major points covered in this program. Choosing the right iron wattage and tip size is important. Tip care is especially important because of long idling times. Most board damage occurs during part removal. It may be safer to cut the part out than to risk board damage. Difficult jobs such as multi-leg part removal should be done by an experienced repair person using equipment designed for that purpose. For example, a vacuum desoldering machine. Use extra care when soldering wires. Melted insulation, nicked wires, and loose strands are unacceptable. Chip parts and other special parts may require a special type of solder. All flux is corrosive and must be removed. Use only approved solvents. Don't use Freon solvent. Circuit coolers can damage temperature or static sensitive parts. Never use a Freon cooler. Excess heat ruins boards. Try not to heat a connection longer than 2 seconds. If more than 2 seconds is required, your tip may not be properly tinned, or your iron wattage is too low. Allow connections to thoroughly cool before reapplying heat. Some specific board materials may not even tolerate 2 seconds of heating. Rivets can be used to repair boards, but by themselves are not a reliable electrical connector. Always solder rivets to the surface pad. Rivets should not be used to complete interlayer connections. External strapping may be used if circuit performance or appearance are not degraded. Lifted or missing runs may be reglued or replaced by an experienced repair person. In short, any repair work should be mechanically sound and electrically reliable. It should not have a degrading effect on overall appearance. No one has more influence on the quality of shipped instruments than you do. Help continue the tradition of quality that has made Tektronix what it is today.